Okay, today I'll be able to give sample problems on power, electrical energy, or computation. Okay. I have here. Actually, there are two problems, but we solved the other problem a while ago, and this one left. This one, because I have no time. This one. Can you see it? Okay. Can you read it, right? I'll give you 2 to 5 minutes to go over the problem. Okay, so the questions are also asking for the cost per month, something like that. Okay, and it has to do something with conversion only. Okay, so I have to read now the problem. A 12 volts battery is connected to a light bulb and draw 150 milliampere of current. What is the electrical resistance of the light bulb? Letter B. How much power does it consume? C. How much will it cost to operate this bulb for a month if the cost of electricity is $0.11 per kilowatt hour? So this is very useful in calculating your monthly electricity consumption billing in your house, in your home. If you have this idea of getting the power, especially if you know the voltages or the wattage of your appliances, and you have to total that, okay, in watts, watts, and then you get a piece of paper and write it down. For example, refrigerator, okay, everything, AC, and then televisions, TVs, like that. Everything that is running permanently or operating permanently in your home, then you can calculate the total power, and then you know also with the billing, right? Monthly billing, the cost of electricity consumption per hour and kilowatts, like that, and you can solve for your own consumption so that you will not be cheated by those electricity provider. Like, because sometimes their computations might be wrong, and sometimes there must be discrepancies for their computation. Okay, so you can really justify your complaints with them. You have to clarify because you know how to compute. Okay, your electricity consumption billing in a math. So this problem is very useful. Okay, like that. So usually expressed in watts siya, not in horsepower, because horsepower only as a unit of power are expressed in plant process or in you know working in a plant, because there's a lot of motor pumps there in horsepower. Not the rated power is horsepower, but in the home the appliances are watts, watts. Okay, and then if you have the meter reading installed in the wall of your house, then you can check that out, and then you can calculate this by applying the Ohm's law, okay, like that, and also the formula of power, like that. Then perfect, you can solve it, okay? Because this is not really complicated. This is basic mathematics along with slight theories in practical electricity only. Okay? This is not the connections too much, because there are also problems in electricity that too much connections like this. We will not deal that here. That is an example of the Kirchhoff's law, right? In electricity, we have also the Ohm's law, and we have also the Kirchhoff's law. The Kirchhoff's law is more complicated compared to the Ohm's law, and of course, Ohm's law is very practical in the real world, not the Kirchhoff's law. Okay? But if you want really to dig it out, then you can go to some electricity topics in the websites or any source of electrical reference materials, and you have to study that. Okay, go over it so you know also how to compute by using the Kirchhoff's law. But in here in this problem, we need only to use the power in relationship with the Ohm's law. Okay? And that's very clear. Okay. So I need to get now scratch paper for formally starting the computation process. Okay. I have to off the AC because I feel cold. Okay. Yes, normally I will feel cold and I have to off the AC. Okay. Because you know sometimes I feel very cold and sometimes I feel very hot, and then I on it and then I off it. Okay. Just like that. Okay. So now I off because I feel cold at this point in time. Okay, I will get now scratch paper, guys. Okay. If you are facing future examinations, okay, especially in sciences, physics, chemistry, okay, like that, then you don't have to worry if you memorize all the basic science formulas, okay? And electricity also is a part of science, okay, because it is electrical energy, okay? Like that. As I explained a long, long time ago, there are a lot of types of energies, right? So mag-feedback mo ang microphone, okay? Okay. So magsugod na ta. Oh, we will start now. Okay. Wait for a while. Hello guys. Okay. Oh, feedback man siya, no? So, wait for a while. Let's write the given, okay, first. And illustrate the circuit. Something like this, okay? So, this is question number 2. Okay, then we have a 12-volt battery. Something like that. Okay? Connected to a light bulb. Something like this. So this is a 12-volt battery, and it's positive terminal and the negative terminal, something like that. Okay? It will flow from a higher voltage to a lower voltage, something like that. Okay? Okay? So positive terminal and negative terminal, this 12 volts. So if it is capital V, that means this is the voltage and the unit is in volt. V-O-L-T. Volts. Okay. Now, it will light, right? Okay. So there's a light energy upon producing the flow of electrons in this path, because it is the electron flow that will give an energy to produce a light, something like that. Okay. So letter A. So the current is I. Always represent that as I, okay, because that is standard. And then standard symbol. And we have 150 milliampere. So it's up to you guys if you convert this right away before substituting to the Ohm's law equation, or either you will just convert this milliampere when you substitute in the Ohm's law. But for me, I will convert first because the standard unit of current is only ampere, so that it will never complicate anymore during the cancellation of the units. Sometimes it confused me. Normally, I'll convert first. Okay, this is also what I did when I took up the board examination. I always convert first to agree the units before substitution. Okay, because it helps me to simplify units. Okay, it makes me easier to calculate very well, something like that. Okay, but it's up to you, huh? If you are good in conversion factors, then this is not an issue. Okay, so I'll convert first. So milli meaning 10 to the negative 3, right? Milli. So we have to convert this one. So 150 milliampere. Okay, so that is milliampere So 1 milliampere is equals to 1 times 10 to the negative 3 ampere. This is the conversion factor. 1 milliampere is equals to 1 times 10 to the negative 3 ampere, or you can write that as 0.001. Okay, then perform the basic mathematics only. Okay, even though without calculator, you can solve this immediately, right, by moving it to the left because that is an exponent of negative. Okay, so this become 0.150 ampere. Okay, like this. Okay, A, just put capital A meaning ampere. Okay, like this. 0.1150 ampere. Okay, we have now the current. Okay, so what is the electrical resistance? So we will use the Ohm's law. Okay, Ohm's law. Okay, I tell you guys, this will come out in the board examination. I think only one item or two items like that, but this is usually mixed in the coverage of physical and chemical principles, because this is also under physics. Okay, this topic is under physics, and physics also is a science. Okay, this is physical and chemical principles, sciences, something like that. Okay, so V is equals to current times the resistance. Okay, like this. Okay, and then substitute values for I, which is 0.150 ampere. Okay, like that. This is our I, right? Like that. And then our voltage is 12 volts, right? 12 volts here, or V. So R is automatically divided by 12, divided by 12. So R will be how much, guys? You can calculate it also by your own. Okay. Okay. So 0.150. Okay. Divided by 12. 0.150 divided by 12 is equals to 0.0125 resistance. Okay, so resistance is equals to 12 divided by 0.150. Okay, sorry, 0.150. It's not 12, it's 0.150 because we need to cancel out the unit of the resistance man siya. Okay? Enroll in mathematics, if you need to find that quantity, you need to cancel out the figure besides that quantity you need to find out. It's not 12, it's 0.150. Or you can simply put that as R is equals to V times I, so that you will never be confused. Okay? And substitute 1 by 1. Okay? So 12 volts divided by 0.150. Okay, be careful ha. Just like me now. Okay? I'm not taking into consideration the rule in mathematics. Okay? I'll just very, very confident. But it was really wrong. And I reviewed immediately like that. Okay? Times 0.150 is equals to 80. Okay? 80 ohms. Okay? Because if you see the answer is very small, you will doubt it, and then you will repeat that one because you have the theory already. So that's the benefit of theory application, because if you found out that your answer is very small and then it's not realistic, then you have to think immediately, oh, this is gonna be wrong. So rather than going directly without thinking the answer, just like that, that's principles. Okay, so if you commit mistake, slight mistake, and then oh my gosh, this is really small, and then I have to go back, something like that. Okay, that's the power of analysis through theory, something like that. Okay, so That's why memorizing without understanding is not enough. Okay? You have to analyze really. Okay? And resistance must be bigger also, not point 0 something, because the relationships between V is equal to IR. When the voltage is increased and the current is also increased, something like that. Okay? Relationships, whether it could be inversely proportional and directly proportional relationships. Okay? So our resistance is 80 ohms. And the omega, this is omega ohms, right? The symbol. Or you can write just only OHMS or write this kind of symbol because I'm used to this kind of symbol only. This is represented as ohm. Okay? So we have now the resistance of ohm, 80. Okay? Now, how much power does it consume? What's this? How much power does it consume? So power, okay, is equal to power is equals a lot of formulas of power. From now on, memorize already. There are 6. Okay. First, power is equals to work over time. Okay. Power is equals to Q times the voltage over time. Q is the electric charge. Power is equals to the voltage times current. Power is equals to current raised to the power 2 times R. Power is equals to voltage squared raised to over R. Okay, V squared over R. And lastly, power is equals to energy over time. There are 6 formulas of power. Okay, please take note that because it will come out to the examination really, especially PRC board examination. There is always practical electricity questions there. Okay, sure, something like that. Okay, so power. We will use this power that involves resistance and I because we already computed the I and R here. Or it's up to you as long as there are values already, then you can substitute directly. Okay, but in here, I love to choose the computed one already. Let's say I squared over times R. Our current is 0.15 ampere. Raised to the power 2, and our resistance is 80 ohms. Okay, so automatically our power is 0.5 times 0.5 times 80. Okay, so 80.150 times 0.150, okay, times the resistance of 80 is equals to 1.8 power. Okay, 1.8 is the power. Okay, so guys, this is the this is the power. This is the power of electricity or electrical energy problem because we don't have to prove the unit. Okay, actually we can prove this also one by one, but it takes us a very long time to prove why it will become watts. Like this, imagine the ampere ohms is equal to the watts already. Okay, because the unit of current is ampere and the ohms for the unit of resistance, and you multiply that one, right? And that is supposedly ohm squared, right? Because you take the resistance raised to the power 2, so ohm squared times ampere. Supposedly ampere ohm squared is equal to the watts. Why? So we don't have to dig it up, because electrical problem is just like this. Your power will be automatically as watts as long as you use the standard units. Okay, standard units in the problem. For example, for voltage, volt. Okay, for electric charge, coulomb. Okay, for resistance, ohms, something like that. So when you obtain the answer of power, automatic watts. Okay, unless it will be changed to another unit there somewhere in your problems, and you have to have conversion factors. But in here, the standard units are used, so no need to worry. Automatic watts, because watts is the standard unit of power. Okay, like that. Unless the question push you to convert with horsepower, then you have to use the 1 horsepower is equals to 746 watts, or the power is given already in horsepower, then all you have to do is convert that into watts to make it standard during your computation. That's why I prefer to convert it first, before substituting to the basic equations in electricity so that it will not become a problem for me and already simplified. Okay, something like that. So our power is 1.8 watts. Okay, now letter C. How much will it cost, okay, to operate this bulb for a month if the cost of electricity is 0.11 per kilowatt hour? There are two ways to solve this one. We can solve this through direct conversion factors and do the mathematics. And we can also solve this through using power is equals to energy over time. Okay? Not the work, but the energy over time. Because the work is always defined as, or the energy is always defined as the capacity and the ability to do work. Then work is technically equal to energy. Okay, something like that. Okay, so again, energy is the capacity or the ability to do work, and then work is equal to energy, something like that. That's why we have another formula: power is equals to energy over time. Okay, and the energy in the numerator, it depends on the unit you will be able to use, but again, as advised, this is always expressed in joules per second because this is equal to 1 watt. 1 watt is equal to 1 joules per second, something like that. Okay, so we have $0.11. We take first the conversion factors first. Okay, so 0.11. So the consumption of your billing in a month, so 0.11 per kilowatt hour. Okay, now we have the answer of power, which is 1.8 watts, right? Convert first this kilowatt hour to agree with the 1.8 watts in our power that we already solved. So 1 kilowatt hour, okay, is equals to 1,000 watt hour. Okay, like this. Okay, conversion factors only, basic mathematics. And then you have to convert the kilowatt hour. What is left is the watt hour. Okay, since you have now the watt hour and you have also the power of 1.8 watts hour, then you can use that one for your conversion. Okay, like that. So we have 1.8 watts. Okay, like that. So multiply that with 1.8 watts. Okay, here besides, you can cancel now already the watts. What is being left is the hour. Okay, now your problem is the hour, but take note, our required or our what is being asked is a month. Then you have to convert hour into months. Okay, it will go to the days, number of hours. So like this, in one day there are 24 hours. Okay, something like that. Okay, and in 30 days we have 1 month, and then bingo, we can solve the consumption of your billing electricity in terms of dollars, okay, over per month. Okay, something like that. So this is by conversion factor. Okay, even though you will not use the formula power is equals to energy over time, but using conversion factor only will do, especially if you forgot the formula. Okay, like this. So cancels na tayo, class. Okay, something like this. Okay, so from hours to a month, convert. In one day there are 24 hours. Okay, in 1 month there are 30 days. As easy as that. Okay, like this. Okay, so the answer will be, my goodness, so 1.8 times 24 times 30, okay, times 1.8 times 24 times 30 is equals to, divided by 1,000. So 0.14256, or let's say $0.14 per month. Okay, you will pay $0.14. You will pay $0.14 per month of your electrical energy consumption, of your electricity consumption in your house, something like that. And then we need to equate this. Let's try the power is equal to energy over time, if we can get the same answer with this. Okay, because this is conversion factor method, and we use the formula method, which is power is equals to energy over time. Ganon. Okay, so power is equals to energy over time. We have now the power equal to 1.8 watts. Okay, equal to the energy here is the electrical energy. Okay, is the electrical energy, because the meaning of power here is really the rate at which the electrical energy is transferred to a circuit. Okay, because we're dealing with electricity here. Okay, and then also the rate at which the work is being done through electrical energy. This is the meaning of power here, electrical power we mean here. Okay, so 1.8 watts is equals to energy over time. Okay, and our time is in month. Okay, like that. This one, substitute power is equals to energy over time, and then 1.8 watts is our power that we already computed, is equals to energy over time, but time it's understood to be month because it is being required in the problem. Okay, now energy is equals to cross multiply, or in algebra, okay, like this, cross multiplication, and then we can obtain energy is equals to the power, which is 1.8 watts, okay, times the time, which is math. But before going to math, let's go back first to seconds, because month is the end point. Okay, we will start to the seconds or hours. Okay, like that, because this is the final point, the month. So 1.8 watts. Okay, and then we have 0.11 kilowatt per hour, right? So 0.11 kilowatt per hour, we will convert that to watt hour, so that it will be satisfied with this watts here. So 0.11, convert first, $0.11, okay, per kilowatt hour is equals to 1 kilowatt hour over 1000 watts. Okay, like that, cancel, okay, something like that. Okay, 1 kilowatt hours equals to 1000 watt hour. Okay, so 0.11 divided by 1000 is equals to 1.1 times 10 to the negative 4. Never mind the exponent, okay, because it will be calculated immediately. Okay, 1.110, and it's already per watt hour. Okay, per watt hour, and then okay, multiply that here, because this is already the power, and this is already involving time here. So multiply this cost per time here. Okay, so we have 1.1 times 10 to the negative 4 watt hour. Okay, cancel the watts, right? Like this. Okay, like this, watts. Okay, and then conversion from hours to month. Okay, so 24 hours is equals to 1 day. 30 days is equals to 1 month, like that. So what will left here is the dollars per month. Okay, dollars per month here. Okay, so let's do the basic multiplication. Okay, so 24 times 30 times 1.8 is equals to times 1, 2, 3, 1. Okay, so if there's an exponent, just move to the left, Okay, so 1.8 watts, okay, times 1.10 to the negative 4, okay, 0.11 divided by, like this, okay, negative 30 siya, right? So that is watt and then watt hour, okay, and then 1 point times 10 negative 4 watt hour, okay, ganon. So 24 hours 1 day, okay, 30 days 1 month, okay, like this. Okay, so 24 times 30 is equals to times 0.001 times 1.8, so equal to $0.14 per month, okay, like this. It's just equal, okay, per month, okay, like that. So this is just the same, $14 per month, okay. You can convert that and you can use the formula, it's the same thing, okay, like that. You understand? Okay, just review that like this. Show your solution in this way also. Okay, it depends on your ability if you use the conversion factors and if you use the basic formula only. Okay, like that. Okay. So, any questions so far? Okay. So it's just very easy, right? Ganun siya. So if you are not contented with your answers, then you have to review like that. Okay. Thank you so much for watching this live streaming. If you think this can add you a little bit of information, then you can subscribe my channel. You can comment down below and then click the notification bell of some newest updates. I am a singer, eternal voice. Thank you so much for watching this video. Bye bye. God bless everybody.